So what we are discussing, we are discussing about the Numpy particular library. Okay. So what is the purpose of using the Numpy particular library? So it is specifically designed and developed to work with the numbers. So whenever I'm working with the numbers, specifically with the numbers, then I have to go with this particular NumPy library. Okay. So you can work with the mathematical functions, you can work with the scientific, or you can work with the stats related things. Like example, you can see here, this is the official website, numpy.org. In this particular website also, you can see here, there is a one definition is given. Numerical Python. NumPy stand for numerical Python. Is a open source, means you don't need to pay anything if you wanted to work with the NumPy library. So it's a Python library, means if I'm using this particular library, means whatever the code I'm going to write, it is in the Python form. So that is widely used in the science and engineering. And the NumPy library contains multi-dimension array data structure, means normally whenever I'm using any particular module, I work with any particular specific task. So if I'm performing any particular task, there will be some particular data will be there. So now if I wanted to hold the data in Python programming language, we have basic data types are there, we have advanced data types also there. So now, but by default, we don't have the array concept in Python programming language. If I wanted to use the array particular concept in Python programming language, then compulsory I need to use the array library or NumPy library. Okay. So now this particular data types holds the n number of particular data which is related to the same type of data. Means in list we can store mixed type of data, but here in array it holds only n number of value but belongs to the same data type. Okay. So here all the particular data, whatever the data I'm storing here, all the particular data we can store in the array format, and array store n number of data, but there is a condition is all the data belongs to the same type. Means if first value I have stored as an integer, then remaining all the values must be integer only. First I'm storing as a float, then remaining all the values belongs to float only. So these are the some particular conditions. Okay. And here you can see here, n dimension means you can store one dimension, two dimension, three dimension. Will come to that particular point also. And apart from that, you can see here this particular library is used for the different particular purposes here, like quantum computing, statistical computing, signal processing, image processing, graph and network, astronomy. You can see different particular domains this particular library is using. And there are many particular companies are there. These companies are hiring specifically Python NumPy engineers to complete their particular work. You can see here there are different domains are there. Apart from the scientific domains, it is also used for the different particular libraries also. You can see there are different libraries are there. With these libraries also we use the array particular concept. And you can see here, you can see there is a dask type of library, and this library is used to for analytics purpose and enabling performance at scale. And now you can see there is a one more particular QPy library is there, which is used for the GPU accelerated computing with Python. There are different work we perform, and for this particular form we use array particular data, and this array data is used in the this type of libraries here. Apart from that, we use with the data science also to extract the data, to transform the data, to load the data, to explore the data, to analyze the data, to create different modules, to evaluate something, to create a dashboards. Okay, for different purposes we are using. We are also using the machine learning purposes also. Okay, and in the machine learning there are different libraries are there. Scikit-learn library is there, TensorFlow is there, PyTorch is there. Apart from that, for the data visualizations, in the data visualization, like there is a matplot library is there, cbun library is there. Apart from the different libraries are there which is used for the visualize the data, means creating the graphical representation format. Okay. So this is the use of this particular library. And in as a data analytics, as a data scientist, as a data engineers, okay, we continuously use this particular NumPy library. And if I wanted to work with the data, we use the array particular concept to store the data and to work with that particular data. Normally still now we are using the individual data types like integer, string, okay, boolean, all these particular data set. And also we have worked with the list, tuple, set, dictionary, these type of data set. Apart from the same thing, we have the array type of data. Okay. And let's go with the some more particular points here. Okay. So if I'm storing that particular data in array, it will be in the matrix format. It may be one dimension data, it may be a two dimension data. or it may be a three particular dimension. Okay. Now let's go with the some more particular points here. So why we are preferring the NumPy over the other particular, uh, there are different particular concepts are there in Python, like we have already built-in functions are there, and like we have other particular data types are there. So the main particular advantages are here is it is very fast. Okay, if I just write here main advantages, okay, is using array to handle store and handle the large data set. Okay, and it is very fast, it is more efficient comparing to uh, other particular data types. It holds the less memory comparing to the other particular data type. Okay, so these are the things are then, and performance also. Okay, if you write the code in the NumPy particular library, it will be give you the good performance comparing to the normal particular functionalities, because it will take less particular time also. Okay, fast means faster execution. Okay, less time. Okay, so these are the some particular important points are there. And here, okay, one more thing, work with multi-dimension data. Okay, so these are the some particular point. Apart from that, these are the some particular points are there. Okay, so these are the some particular advantages are there if I go with the NumPy library. Now next question is how to use this particular library. How to use the NumPy library? So first of all, you have to install the library. Okay, how you're going to install? You have to open the command prompt, and then you have to type, make sure it will be in the administrator mode, and then you have to type pip install numpy. Okay, and after that, after installing after installing go to the editor and then import the numpy module. Okay, so how to import? You can import numpy. Okay, so this is the way like how you're going to use this particular numpy library. Okay, so let me just open the command prompt here, and here I'm going to use run as administrator. Okay, so once you open this, simply you can type here pip install. Okay, and once you enter this, it is going to start the installation. Okay, it is showing like in my particular laptop it is already installed. So once it is installed, now you have to check using the import command. So here I'm going to use the import numpy, and I'm giving the reference variable name as a np. Okay, now let's understand how we can store this particular data here and how we can work with any particular data. So simply what I'll do here, I'm going to store some particular random values, and we are going to compare like uh, if I use this particular NumPy library or any particular library, uh, normal particular data type, what will the differences will be there. Okay, so here let's use one variable a equals to numpy dot random value. So if I mention some three random values, and once I run this a, you can see here the three random values are stored in the array format. Okay, and if I mention something five, you can see here some five random values are stored here. Now what I wanted to do, I wanted to store some more values. So 10, 100, 1000, 10,000, 1 lakhs, 10 lakh, 1 crore. Okay, 1 crore values I wanted to store, and now it is stored here 1 crore values. If I wanted to check here, I can check using the a dot size command, and now you can see here there are total 1, 10, 100, 1000, 10,000, 1 lakh, 10 lakh, and 1 crore values are stored. Now what I'll do here, I'm going to use one particular library. So this particular library is used to get the time of execution, like how much time it is required for the execution. So simply what I'll do here, I'm importing that particular library, import time, and here I'm going to take one more variable to store the time. So here there is a time library, in that there is a time function is there, and here I'm going to use the normal Python function to get the average of the this 1 crore random values. So here I'm going to take sum of the variable divided by length of the variable. This is the average formula, right? And I wanted to print how much time it is consuming to execute this total 1 2 lines here. So simply I'm going to print here time, the starting time, okay, minus actual time here. So that is b here, okay. And once I run this, now you can see it's loading, and you can see here some 1.743. Okay, this but 1 second 74. Okay, 1.74 second. It is taking this particular time to execute this particular result. Now, what I wanted to do, I wanted to use the NumPy particular library ready-made functionalities to execute this the same particular average function. So in the NumPy, we have mean function is there. So using the mean, we will get the average. So here I'm going to use the mean particular function, and simply I'm going to change the code here, and here I'm going to write NumPy dot mean function of the a value. Okay, remaining code are same only. Okay, and I'm going to run this particular code, and once I'm going to run this, now you can see here how much time it is taking, 0.02. So which is faster? You can see NumPy is very fast comparing to your particular calculation. So whenever I work with the numbers, then compulsory I need to work with the NumPy particular, okay, because it will give you the fast execution. This is a very efficient way, performance way also. If you're developing any particular application, also if you work with the numbers, and if you use the NumPy library and array particular concept to handle your particular any particular calculations part, to any particular process your data, loading the data, exploring the data, analyzing the data, means the performance wise also your application will boost. Okay, your application is going to be give the proper particular executions and the proper result in the very efficient manner, in a very fast manner, and the performance was also it will be good if you go with the NumPy particular library and array particular data type concept to work and handle the particular data. Okay, now let's understand how we can store the data in array particular format. Okay, so let's add some particular points related to the array. The first point is, okay, so what is the array here? So simply it's an ordered collection of homogeneous data type. Homogeneous means same type of data. Okay, so what it means here, ordered means here, all the values are stored in ordered format. Ordered format means here indexing is allowed here. Okay, apart from that, homogeneous data type means, okay, you can store n number of values or data in one variable. Okay, in one variable, but the condition is, what is the condition? Condition is all the data belongs to same type of data. Same type of data. Okay, one more point here, how we are going to store this particular data. So if I wanted, okay, how to store the data, so if I wanted to store this particular data, there are types of array are there. So what are the types are there? So first we have one dimension, second we have two dimension, and third we have three dimension. Okay, one dimension, two dimension, and three dimension. Now, what is this one dimension, two dimension, three dimension here? So here, whenever you wanted to store, okay, one particular row and n number of columns. Okay, so whenever you want to store one row and n number of columns, then you can go with the one dimension data here. Okay, and what is the declaration defining what is the aspect here? Aspect of the variable, right? In the aspect means we'll be having declaration defining and accessing the data. So declaration defining both will be in one particular part here. Okay, declaration and defining. So how we are going to declare and define? So what is the syntax here? Syntax is very simple. Just you have to give some particular array variable name. You have to give some array variable name, and then you have to mention the equal symbol, and then you have to use the numpy function. Then you have to mention array, and then here you have to mention one square bracket, and then okay, you can mention some particular values. Okay, so this will be your data one, this will be your data two. Like this, you can store n number of particular data. Okay, so in this particular format, you are going to store this. And how you're going to access this particular data? To access this particular data, simply you can use the array variable name, and here you can mention which particular value you wanted to access. Okay, so here you have to mention index of column value, index of column value means data one means this is the first column, data two means this is the second column. So how it is going to work? It is going to work as a rows and columns. Example purpose. Okay, let me give you one example. Just assume there is one house is there. There is one house is there. And just assume this house are having only one ground floor. And in that particular house, there are some four rooms also. So it means this ground floor will be considered as a one row, and this four room will be considered as a four columns. Clear? Okay, so this is the way like how you're going to work with the one dimension. One dimension is only one row and n number of column will be there, and whenever I wanted to access the data, I need to mention the indexing. Okay, and same thing, same indexing concept also remains same. Okay, indexing will start from 0 and we count from left to right form. Okay, example, just assume we have stored a1 equals to numpy dot array, and we store some particular data, something like 10, 20, 30, and 40. And if I wanted to access any particular data, so what I'll write here, I'm going to write print, I'm going to mention a1 of 0. So then what I'll get here, I'll get here 10 as a result. Okay, so this is the way like how you're going to work with the one dimension data here. Okay, so when we go with the one dimension data, simple concept, whenever you are storing only one row but n number of columns are there, so simply you can go with the one dimension data in the array particular format. Now, let's go with the two dimension data. What is the two dimension data? So here, whenever you want to store n number of rows and n number of columns, okay, then you're going to work with the two dimension data. Example purpose, Just assume there is one building is there. Okay, in that building there are some three floors are there. In that particular three floors, just assume each floor each floor contains, just assume, 5 rooms. Then this building will be considered as a main structure, and this three floor will be considered as a rows, and this rooms will be considered as a columns. So this is the two-dimensional structure. Simply two-dimensional structure means whenever you wanted to store the multiple rows, and each row contains multiple values here. Okay, and what is the syntax here? Syntax is very simple. Syntax, let me copy. Okay, so here first of all, same thing, you have to mention the array variable name, and then what you need to do, first of all, you need to create the main structure. So this will be a main structure, and inside of the main structure, now you're going to write some particular rows here. Okay, so again you can write in one more particular row, you can write one more particular row, like this you can write n number of rows here. So this will be as a your row number one. Okay, this will be your row number two. Like this you can keep on increasing the rows here, and this will be considered as a your particular column value. Okay, like this you are going to store the particular multi particular rows, and each row contains n number of columns. Okay, that is the 2D structure here. And how we are going to mention here, here you have to take one more particular uh, square bracket, and this square bracket for the row index number. Okay, and next you have to mention the column index, means second row I want first column value, third row I want second column value. Like this you can mention the specific row index, and then you have to mention the column index, so then you can easily get those particular values here. Okay, clear? Any doubt, any questions? Now
Yes, sir.
let's
Yes.
go with the 3D structure. What is the 3D structure? So whenever you wanted to store the data where blocks are there, and each block contains some particular rows, and each row contains some particular columns. Okay, so let me add this point. So whenever I want to store the data where I have some blocks are there, and inside of the blocks, okay, you will be having, and inside of the block, okay, rows, and inside of the rows you have columns. Example purpose, let's take an example here. There is a one campus is there, so campus is my main structure. Inside of the campus, just assume there is a multiple buildings are there. Just assume there are three buildings are there. Now each building, okay, each building contains some particular uh, floors here. And now, okay, for example, let's assume 5 floors are there. Now just assume each floor contains, okay, some rooms are there. Just assume some 8 rooms are there. Okay, 8 rooms are there. So here your buildings will be considered as a blocks, your floor will be considered as a rows, and your room will be considered as a column. This is called 3D structure. You can assume there will be one make my trip website is there, or something like book my show website is there, and you wanted to book something. Okay, in the book my show website, like if you wanted to book a movie ticket, so there will be entire main particular area will be there. Inside of the main area there will be seat selection like this. Okay, if I just open one paint. Okay, so just assume this is your main structure, and just assume this is one particular area is there. Okay, there is a one more sitting area is there, and there is a one more sitting area is there. Okay, and there will be something mentioned. Okay, just assume this is your uh, something A1 block is there. Okay, and just assume this is your some A2 block is there, and just assume this is your some A3 block is there. Okay, so now each and every particular block again contains some particular rows. Just assume this is one particular row is there. Okay, and inside of the row, just assume there is one seat is there. Okay, this is one seat is there. Okay, again there is a one more seat is there. Okay, just assume there is a one more seats are there. Okay, so like this there will be different rows will be there. You'll be having multiple rows, right? Okay, now I wanted to book some particular ticket. Just assume I wanted to book this particular ticket, or else I wanted to book this particular ticket. So how we are going to book this particular ticket? So here there will be something like A1. Okay, something, just assume this is the row number 1, this is the row number 2. So something like row number 1. Okay, you have third seat will be there. Okay, like this some number will be there. Okay, means this will be some block is there, some row is there, and some particular seat number will be there. So this is actually the 3D structure. Is it clear? Yes, no?
Yes.
Okay, so whenever you wanted to hold this type of particular data, where a complete one particular structure is there, and this structure is divided into different blocks, and each block contains some particular rows, multiple rows, and each particular row contains some particular column values. So this will be first column value, this will be second column value, third column value, fourth column value. Again second row, again first column value, second column value, third column value, and fourth column value. So you have to go with the array concept. Okay, and what is the syntax here? How to store the data? Let me copy this. Okay, so when you are declaring any particular data, so first of all what you have to mention, you have to mention the main particular structure. You have to mention the main structure. So first main structure will be there, and inside of the main structure again you have to create the block. So here just assume here you are creating the block one, and inside of this particular block, again some particular data will become block 1 row 1, block 1 row 2, block 1 row 3, like this. Again one block is completed. Okay, you can add comma, again you can add one more block. So this will be a block number 2. Okay, and block number 2 row number 1, block number 2 row number 2. Again you wanted to add one more particular block. Okay, you can add one more block, just as in this is your block number 3. Like this you can create n number of particular blocks here, and each and every particular block contains some particular rows values, and each and every row contains some particular column values. Okay, and okay, this is the way. And here how we are going to access? So first of all you have to mention the block index number, then you have to mention the row index number, and then you are going to mention the column index number. So this is the way how you're going to access the 3D structure here. Okay, so let me revise once again. One dimension data means only you will be having only one row n number of column values. Two dimension data means whenever you wanted to store the n number of rows and n number of columns values. Three dimension data 3D structure means where you have the first block wise, inside of the block there will be rows will be there, and inside of the rows there will be column will be there. So you can create n number of blocks, and inside of the blocks you can create n number of rows, and inside of the rows you can create n number of columns. Okay, so this is the way like how you're going to store the data here. Okay, now let's understand one more way. Like if I go with the normal list, can I do the calculations or not? If I go with the array, what will be happening? So now you can see here I'm going to take one more particular way, list versus array. So here I'm going to take two lists. Let's assume list 1 equals to, let's store some data 10, some 20, 30 and 40. Okay, let's create one more list, and here I'm going to give the list 2, and here I'm going to store some 50, some 60, 70 and 80. Okay, and if I write here list 1 and list 2, so what will happen here? So it is not doing any type of calculations, it is doing the concatenation, means joining that particular two or more particular list, and you can see here continuously it is going to print. Now what I'm going to do, I'm going to take two particular variables. Just assume this is my array 1, and just assume this is my array 2, and here I'm going to store this as a numpy. So here I'm going to use numpy dot array format, and here also I'm going to store the same particular numpy dot array format. Okay, and once I run this, if I write now array 1 plus array 2, now you can see the differences here. So it is doing the calculations. Okay, so this is the way like why we are preferring the numpy particular array concept over the normal particular Python functionalities. Okay, so whenever I'm working with the numbers, compulsory I prefer the numpy particular library. And if I wanted the efficient way to write the code, better particular performance, less memory I wanted to occupy, okay, and the execution should be happening in the very faster way. Okay, it should take less particular time, and easily I can handle my particular data also, and I can work with the multiple particular dimension data. So simply I can go which concept I can go with the NumPy particular library. Inside of the NumPy library, if I wanted to handle the data, I can use the array particular concept. Clear this point? Okay, so that's it for today. In the
Yes.
next class, we are going to understand how to store the one dimension data, two dimension data, three dimension data, and what are the built-in functions are available, what are the different operations are available related to the array. Okay.
Yes.